So this is the assignment which we will be attempting. It's once again a simple portal frame. We've done something similar to it using profiles. The difference this time is that all these elements, all these columns and beams have been entered using plates rather than profiles. So you see that the plates actually change thicknesses as well at certain points. All these details are given over here. So you can see how the plate is changing thicknesses from, let's say, a 25 millimeter plate to a 20 millimeter flanger. And you can see the 3D drawing over here as well, where it's probably clearer to see that you have these distances where the flange thicknesses change. It's at 4,000 on the inside, 5,000, 4,000 at the outside, 5,000 at the inside, along the slope, and it changes from 20 to 25 millimeters, and the web also changes at a certain distance. Those distances are all given over here, and the basic exercise is that you have to, once again, we have notes which give us all the information. And the basic exercise is that we have to use the built-up tapered frame macro to enter these elements. So we get to know and understand how this macro works. So the first thing which we note is that the grid has been set up as 24,000 in the x direction. The columns, the vertical column on both sides, because it's a symmetric structure, have a height of 8 meters, and they're tapered, and they're made using plates. And the outer flange and the inner flange both change. So this one, if you zoom in, you will see that the outer flange changes. You can see that in detail 3. So let's go to detail 3. Over here, you see the outer flange has a width of thickness of 20 millimeters, and it changes to 25 at a certain level. What level is that? Let's go back in again. It's the level at 6,000. Sorry, it's the level at 4,000 from the bottom. This is that point. And then, as far as the inner sloped flange is concerned, that one changes at a sloped length of 5,000. So when the slope length reaches 5,000, we have detail 4. Let's go to detail 4. You see once again the 20 millimeter flange is changing to a 25 millimeter flange over there. And furthermore, let's go up again. We see that the web also changes thickness from an 8 millimeter web to a 10 millimeter web at a height of 6,000 from the ground. The total height is 8,000, and the web height starts off with 300 millimeters and ends at 1,000 millimeters. So these are the web heights. These are not the total heights, the heights of the web plate only. So the total height at this point will be somewhere around 1,050 because of the 225 millimeter flanges. But all those, so you can see that point, for example, the total height of the inside of the web, the total height of the web plate is 1,000 millimeters, and then you have the 25 millimeter for the flanges. So all those dimensions are given. We'll just keep those in mind as we enter the columns. So we've set up the grid at 24,000, and the way we enter these tapered elements with plates is by using the built-up tapered frame macro, which is under the structural members. So you can find it over here. And the way to use it is you just click on it, and then you select 2 points. It's like entering a beam. So even for the column, you will select 2 points. And for the beam also, you'll select 2 points. And then you'll make the modification. So let's start by trying to enter the column. So we click on that. We select this start point. And we know that the height of the column has been given as 8 meters. So we hover over the same point and we say EZ 8,000, like that. and it creates a basic member which is made of plates, made of 3 plates. It's not tapered, that's the default, but it is made of plates. So then if you want to change it, you will just select any one of those plates, click on M and enter, and it's going to open the dialog box. And the dialog box has several tabs. This tab is for the general tab is basically for defining the webs. You can have up to 6 different web heights, and as you choose. So, for example, because we'll have a intermediate location where the web height changes, so the web height will start from 300, and then it's going to have a different height over here, and finally it's going to have a height of 1000. So it'll have 3 heights. So what you can do is you can choose 3 over here, and when you do that, it allows you to enter H1, which is the starting height, H2, which is the final height, and H3 you can make it calculate automatically by choosing the linear interpolation, unless you want to actually enter H3 yourself. And you can also change the web thicknesses at those for the first web and for the second web after that point. So it's pretty simple. So let's zoom in over here. Right now it's placed like that, so we'll need to change this from behind to front. If we do that, we see that it goes to the correct orientation. Now I've changed it to 3. It's got the 3 defaults in there. This is not what we want, but we'll get to those. Similarly, after making up or changing our parameters related to the webs, we can go to the flanges section. And here we have the upper flange and the lower flange, and these definitions will sometimes the upper will be this one or the other one, depending on how it's oriented. So it's a bit of a trial and error, but it's easy to find. And once again, you can choose the number of upper flanges. How many plates do you want to change? So if you want this to be 2, in our case, you want 2 upper flanges and 2 lower flanges, or 3 lower flanges, or whatever, you can do that. Once again, you'll enter the thicknesses over here and the lengths of each member over here. So what I've done is I've already created a preset for the column which we need. I'm just going to load that and select that and say load and say apply, and it basically creates the column which we need. Let's go and check the entries. So we go to the general section, which is for webs. You see that it starts off with H1 300. The last one is 1000, and we leave it to calculate the third one. The first one is 2000. The L1 rather has been given as 6000. This L1, and the L2 is given as 2000. So we might need to change that. Let's go and see what our requirements are. So we know that our L1, our height where the first flange changes, is 4000, and the second one is 5000 actually. So it's different over here, 4000 and 5000. So if we go back in there, the L1 should be this L2 is from the end. Rather, or no, I'm sorry, this is for the web, it's not for the flanges. So yes, this is 6000 L1, which is the distance from the start, and that's exactly actually what we need, because this 6000 is where the web changes thicknesses, where the web splice exists, if you will. So it's 6000. So we come back over here, and this is what L1 is, with the web changes, and then whatever is left for the last part. And if you go to the flanges, you will see that this is the lower flange is basically this one, this one, the straight one, and it's given as 4000 with a 20 millimeter and 25 millimeter thickness. And the upper flange, which is the inside one, if you notice the first one, which was given as 5000 along the sloped line. Let's go back. This 5000 over here, 5000 along the slope line, and then whatever is left. So let's go back over there. We say if we enter 5000 over here, it's going to calculate the whatever is left on along that length. So with these inputs, basically it's very easy to just go and say apply, and we'll get the required column. Now for the beam entry, we should note that at this point, there's a detail 1 over there. So if we go zoom into detail 1, you'll see that the beam starting point is actually offsetted. It's not offsetted, it's actually exactly vertical from the 0 point. It's that the flange is offsetted because the flange gets thicker. So it starts off with 20 millimeters and then it's 25. So the flange is jutting out. So we need to make sure we don't snap to the middle of the flange point, but rather the middle of this point, which is 5 millimeter offsetted, to make sure that this point is directly above the 0 point at the bottom. So just need to make sure of that, and we can go in and go to the model and go to once again the built up member. So you can see what I was saying was we don't want to snap to this middle point because that middle point is offsetted. We want to snap to a point which is 5 millimeters in. So I just created that point just to highlight it. And so we click on that point, and then we hover over the middle of the grid, and we say DZ 12,000 because the height of the apex is given as 12,000, like that. And once again, a default member is created. Once again, if we go back and check, this time the web changes after 2 meters. It starts off with a thickness of 10 millimeters, and then the remaining element is a thickness of 8 millimeters after 2 meters. And similarly, the flanges, the top flange changes at 5 meters, and the bottom flange changes at 6 meters along the line. They all change from 25 to 20. And the final height, the starting height is actually, there's a detail 8, which tells us that the starting height of the beam is actually 1200 as far as the web height is concerned. So the web height starts off at 1200 and ends at 400, which is the web height at that point. So with those parameters in mind, we go back to the model. I've once again saved away a preset to make this faster, calling it beam 1200 by 400 by 10 by 8 by 25 by 20. Select that, say load, and say OK. And we get our beam, enter. These are all separate plates. See, this plate has a length of 5,000 where the thickness changes. You can see the thickness changing from 25 millimeters to 20 millimeters at that point. Similarly, this bottom one has a length of 6,000 and the thickness is changing from 25 to 20. And similarly, the web is at a distance of 2,000 from that definition point, and the thickness of the web is changing from 10 millimeters to 8 millimeters as the requirement was. And once we have that, we can just mirror it to the other side to get the required thing. Basically, the idea over here with this exercise was we've done something similar using profiles, tapered members, which you can just enter by using beams and columns. But first of all, they don't allow you to change thicknesses of the flange along the, and they don't allow you to stagger them and offset them relative to each other. So this one is more realistic in that sense, and it allows you to save away presets. And once you've got these typical presets saved away, you can actually easily load them and then play with these numbers. Let's say you're doing a different one. Let's say the basic format is the same. One change is, or two places where two thicknesses for the top flange, two thicknesses for the bottom flange, and two thicknesses for the web. You've got that saved away. All you need to do is just change these numbers in some other application which you might be doing, and you can use the same presets repetitively as well if you want. So this is the idea of using the built-up tapered frame macro to create your pre-engineered building PEB type tapered members using plates rather than profiles.